Today's lesson is a vocabulary lesson. Our learning target is I can identify and describe parts of an algebraic expression or equation. So our vocabulary lesson has to do with all those algebra words. If I scroll down, you can see the words that we're going to be defining today are variable, coefficient, constant, term, expression, and equation. These are words you probably often heard your math teacher say, but it's important that you understand what the words actually mean because they're super foundational for any algebra skill that you're going to learn. This lesson's targeted more for 7th grade students before they get into expressions and equations and inequalities. However, it's beneficial for even 6th graders, 8th graders, Algebra 1 students needing a refresher on these terms. So I'm going to go through and I'm just going to define them. And then below these definitions, I'm going to be kind of annotating an equation and kind of applying these words. So just kind of hang with me as we kind of go through and just define the terms. So variable is a letter that represents a number. A coefficient is a number multiplying the variable. A constant is a number that does not change. A term is one part separated by a subtraction or addition sign. An expression is a math or math terms without an equal sign. And an equation would be math terms with an equal sign. So let's look at how these words actually apply to an equation below. So when we look at this equation, we have 3x minus 6 equals negative 18. The first thing I want to do is I personally like to look at how many terms do I have. And terms are separated by an addition or subtraction sign. So one way I teach my students when they're going to go and do to count how many terms they have is you kind of start with the first term, and when that number or letter ends before the next addition or subtraction sign, you're going to draw a line. So meaning 3x, and I'm going to draw a line here. So 3x is one term. The next term is negative 6 or subtracting 6. So every term is separated by the addition or subtraction sign. We'll keep our sign with the term so that negative sign or that subtraction sign stays with the 6. So our next term would be negative 6. There is an equal sign. And then we have negative 18 would be our next term. So there was a total of 3 terms here, 3x, negative 6, and negative 18. So all these terms, again, checking your definition, they're one part of like the equation or expression that's separated by a subtraction or an addition sign. So now we're going to kind of piece apart this equation by kind of looking at each thing individually. So first things first is I like to identify the variable. So the variable, or the only letter in this equation, is x. So x is a variable. It's our only variable. Then I like to check to see if there's a coefficient. A coefficient, remember, is a number multiplying the variable. So when I look at that variable x, I see a number right next to it, and there's a 3 there. That 3 is called our coefficient. So that 3 next to the x means that 3 is actually being multiplied by x. Okay, so the coefficient, that number that multiplies the variable. So when we say 3x, it really means 3 times x. If I look at the rest, since there's no more variables, there's not going to be any more coefficients. So I've now labeled variable, I labeled coefficient, I labeled terms. So the other word out there was constant, and so the number that does not change. So essentially a constant is any number by itself, like -6 or -18. Those are all considered constants because those values don't change. Like you can identify -6 in a number line. You can identify -18 on a number line. They don't change. And we'll kind of dive into these topics a little bit more in the next couple pages. Lastly, we have expression and equation. So another way people define equation is essentially, if I wasn't keeping my definition so short, is an equation is made up of essentially two expressions being equal to one another. So on here, essentially, this side of the equation, 3x minus 6, is one expression. And then -18 on the right side of the equation is essentially another expression. So these expressions, remember, don't have equal signs. So 3x minus 6 does not have an equal sign. -18 does not have an equal sign. So those expressions, there's two different expressions there. And then because there is an equal sign, when you have one expression equaling another expression, when you see that equal sign, that means that this whole thing is your equation. 3x minus 6 equals -18 is the whole equation. So hopefully this helped you kind of think about what are kind of quick definitions for these terms. How do these terms actually look in an equation that I'm definitely going to see at this grade level? So let's go on to the next page. So we're going to go through a couple of different examples. Notice that I have the equation back up top here, 3x minus 6 equals -18. So these questions you might have answered, but we'll see how well you are following along. So the first question says, what does 3x mean? Okay, so we talked about when you have a coefficient in a variable, there's actually a hidden symbol in between there. 3x means multiplication. It means 3x means 3 times x, or 3 times x. Whatever symbols you want to use for multiplication. We like to not use the x symbol for multiplication anymore. And so that's essentially what 3x means, and that's important. So if you look at questions 2 and 3, it's asking you just to evaluate this expression. 3x, again, is an expression. It's a part of this whole equation. It's a term. A lot of different words that you can use for 3x. So number 2 says, if x equals -2, then 3x equals what? So I would substitute x for -2, and that means 3 times -2 would give me -6. So if x equals -2, then 3x would be -6. If x is 10, then I would do 3 times x, which is really 10. So I'd replace x with 10. 3 times 10 is 30. So 3x equals 30. So again, getting you used to the idea of when you have a number and a variable next to each other, you're going to multiply them. So we obviously don't know what x is, so we just write 3x. But if we did know what x is, like in questions 2 and 3, then we can actually evaluate that part of the expression and figure out what value does 3x actually have. So again, question 4 says, when x changes, what happens to the 3x term? So basically, the value of 3x changes based on what x is. So like in question 2, 3x was -6, but in question 3, it was 30. It totally depends on what the value of x is. So when x changes, 3x is going to change. So then question 5 is asking you essentially, why do you think the terms 6 and -18 are called constants, right? It's something that we labeled before. Again, a constant means a number that doesn't change. So in a nutshell, basically, if you have a term with a variable like 3x, your value is going to change. If you have a term with no variable, which is essentially in most cases a constant, then the value stays the same. Meaning, if you look at -6 and -18, like -18 is -18. It's not going to change. -18 is just a number. It's something you can find in a number line. There's no variable attached to it that would change the value of that term. So I have kind of a notice box at the bottom as a quick reminder that says if x changes, then essentially 3x is also going to change. And then if 6 and -18 stay the same because they're constants. Okay, so if x changes, 3x changes. If 6 and -18 stay the same, then they're going to stay the same. So our second example on this page is about getting into fraction coefficients. So in this equation, we have 2/3 x minus 1 equals -7. So what does 2/3 x mean? Again, just because it's a fraction, it means the same thing. It still means multiplication. 2/3 x means 2/3 times whatever x is. So again, a coefficient, if we go to the next page, we're going to kind of summarize. So when you have a number and a letter together, to summarize, this means multiplication. So when you have a number next to a variable, right next to each other, that means multiplication. So 1/2 is our number. That's called our coefficient. X is our letter, which is our variable. So a number and a letter, a coefficient, a variable, that means multiplication. So let's look at our third example here about invisible coefficients. So we'll start with the left side. It says an expression, x plus 3. What number do you think is multiplying x? Now, a lot of students like to say, oh, there's nothing there. There is something there. It wouldn't be 0 because if 0 was in front of x, that would mean 0 times x, meaning no matter what x is, this whole term would be 0. And so we wouldn't even put the x there. So it's not 0, it's not nothing. The number that's actually multiplying x is actually a 1. Another way you could write this essentially is 1x plus 3. In math, we don't usually like to write the 1. If we have an x, we just write x. We just usually like to say if we have more than 1x. So if we have more than 1x, that's where you'll see that 2x, that 3x, that 1/2 x. Essentially, if we don't have a single x, then we need to denote that by giving it a visible coefficient. So our coefficient of x here is just 1. And we can kind of prove that by evaluating this expression for x equals 2. So if we look at x plus 3 and we plug in 2 for x, we'd get 2 plus 3, which is 5. Now, if I do the same thing with 1x plus 3, right, putting that actual 1 in front of the x, this means 1 times x, which is 2. And by multiplying it by 1, it doesn't change anything. 1 times 2 is still 2. 2 plus 3 is still 5. So it checks out whether I'm using x plus 3 or 1x plus 3 to kind of prove that the coefficient is 1. It's not 0. So if we look at the right side, you'll see kind of how it's similar, where we have an expression that says -x plus 4. So thinking about what number is multiplying x is similar to what we just talked about. There is a number multiplying x, and in this case, it's like -1x plus 4, where the coefficient of x would be -1. That should just say x. So we have -1 is our coefficient. And again, we can prove this, okay? So if we look at the original expression, -x plus 4, and we substitute for 2 again, we would get -2 plus 4, okay, which is +2. Or I can do -1x plus 4. Same idea, I'm going to do -1 times 2 plus 4. Well, -1 times 2 is -2, plus 4 is still going to give me 2. So when I'm subtracting x or multiplying x by -1, it's the same thing. So again, trying just to prove the fact that there is actually a 1 there, or a -1 there. And it's really important that you just understand that if there's no number written in front of a variable, there's still a coefficient. That coefficient is 1. And if there's a negative sign in front of that variable but no number, the coefficient would be -1. And those are really important to understand, especially as we look into this last example here. So our last example is still about, it's going back to fraction coefficients, but it says, question 1 says, what is another way to write x divided by 4, or x fourths, to show that x is being multiplied by a number? So if you notice here, I said this as x divided by 4. I want to know what is a number that could be multiplied by x. So meaning, like, what is the coefficient of x essentially? And it's not 4. If it was 4, we would write 4x. So if you think back to our previous lesson, what number is always in front of x? 1. So we think about this as like 1x divided by 4. Another way of thinking of that is 1/4 x, or 1/4 times x. So dividing by 4 is the same thing as multiplying by 1/4. You can also prove that again by kind of using your coefficient knowledge of what number is really in front of that x. But it's important to understand that, especially when you go to solve equations, that when you see x divided by 4, another way to think about it is 1/4 times x, or 1/4 x. So thinking about not just division, but also multiplication. So then if you look at the second example, it's the same idea. Well, we're kind of looking at -1x divided by 3, or sorry, -1/3 x, or -1/3 times x. So that coefficient essentially is -1/3. And in this example, our coefficient was 1/4. So I hope this lesson helped you understand the differences between coefficient, variable, terms, constants, help you understand a little bit more about the words that are used, and maybe give you some background before heading into some expression or equation lessons. I have other videos on expressions in my YouTube channel, so feel free to look at those after completing this lesson. And I hope you enjoyed today's videos. Thanks for watching, and good luck.